Welcome everyone. Good morning for those of you on the Americas. Good evening for those in Europe and Africa, and well, maybe it's later even in Asia. So happy that we are going to start this set of BRT webinars. And the topic of this series of webinars are going to be towards electric public transport, navigating the transition. And what we would like is to have different opinions from actors that are involved in this. We are going to start with two operators with big experience around the world. We have today Thomas Laverne and Neil Smith, one from former CEO from Tower Transit, and Thomas from the group Transdev, who had a lot of experience using public buses and electric buses in different settings. And as a start, and to put the topic in context, we have an intervention by David Hensher, who, since he's from Australia, couldn't connect today, but we have recorded him. So we're going to go ahead first with the introduction to setting up the topic, and then we are going to ask our two invited speakers to comment on their experience using electric buses and what are they see the main challenges on this transition. So we go ahead with the video. Jose, please.
Good morning, David Hensher from Australia. Sorry, I can't join you live today, but the time difference is not a very attractive option. I've been asked to give a few introductory remarks about the public transport sector of buses in particular as we transition from diesel to clean energy. And I would want to go through not only the technologies and some of the costings, but also some of the challenges in procurement. So I'm going to try and share my screen as I record this, and hopefully this will work, and take you through fairly quickly some of the issues that I think are very important in determining where we need to give the greatest amount of thought to the topic. So we've written a lot about this and published it, and I'd like to begin off by highlighting the fact that the full life cycle from well to tank, tank to well, or well to wheel is very important. And although a lot of the focus is on emissions at the tailpipe, there is still an increasing number of emissions occurring throughout the full life cycle. And we need to recognize that and ask ourselves to what extent we can actually contribute to removing them as well. Generally speaking, we find that roughly 80% of the CO2 emissions are coming associated with the tailpipe of the bus. So if you can convert from diesel to clean energy, then you are definitely saving a significant amount of CO2. And that is very encouraging. Although I should add that 80% doesn't recognize the presence of emissions being created by the tires when they hit the road and rotate, as well as the braking systems, which create a huge amount of emissions. Regardless, let's say roughly 70% of the emissions are reduced as a consequence of converting to clean energy in buses. Also should mention that a great deal of the options that we have available to us do involve charging in locations other than the depot, but there is a tendency to date for the bus operators to prefer plug-in charging at the depot, which in itself raises some quite important questions, putting costs aside for now, about the capacity of the depot to be able to accommodate an adequate amount of charging, let alone the availability of sufficient energy coming off the grid into the depot, which means that there may be other ways looking into the future of which they could complement rather than be an alternative per se. Plug-in charging, where you do some of it through where the vehicle is on the road, using pantographs, for example, where you have conductive charging with physical net connections, or inductive charging where you've got a wireless arrangement underground. And now these are quite expensive, but they are starting to develop in some countries. But most importantly, it's worth recognizing wherever you charge, there's also a huge amount of electricity being generated through the onboard regenerative braking systems. So that's very encouraging. But I do want to remind you that depending on who has to take the risk of depot refurbishment, that there are other alternatives, but they are not necessarily under the control of the operator. Quite an important set of numbers, which I want to share with you here, but more importantly, is the energy or fuel cost per 100 kilometres of the various fuels. And there's no doubt about it that batteries, electricity is actually the most attractive at the moment in terms of the cost, considerably lower than diesel, but also, generally speaking, lower than hydrogen, especially at the preferred source, which is green hydrogen, which at the moment is about $7.70 a kilo, although it's forecast by some international agencies to be as low as $1 per kilo in the future. Well, if that happens, that's going to make hydrogen extremely attractive, but it's highly questionable as to whether we'll get to that number. There are other sources of energy, which I won't be talking about here, but just to refer them to, one being renewable diesel, which is quite expensive at the moment, as you can see from the last column, but it uses recycled water plastic, and some suggest in the next 5 years it'll reduce CO2 emissions by 90% compared with diesel from fossil fuels. It's interesting, this one, because it means you can basically have existing vehicles running on diesel, but reducing the CO2, and then you don't need to change the depots. Indeed, you don't need to change very much at all. Which raises a very interesting question about how much investment are we putting into depots for battery and subsequently hydrogen that runs the risk of stranded assets if a better energy source comes up that doesn't require such a significant investment in conversion of the depot, let alone conversion of the vehicle. Because I think diesel buses will be around for a very long time. The transition will be very slow in many countries. It's worth mentioning that battery technology, which is a key component of this whole exercise, is changing so fast. And even when I prepare this slide, late last year, there's been further developments. But the important thing to note is there are two dominant types of batteries in terms of their configuration: the iron and phosphorus batteries, LFPs, and the nickel, manganese, and cobalt batteries, NMCs. LFPs are the most popular. They are slower to charge in general, be it on the slow charge time or the fast time. Those differences in charging clearly are important because it impacts on how many buses can be charged at any one time, how much energy is coming in that you need to be able to charge at scale, and of course the cost of doing so. And this is going to change quite radically because we're starting to find that in the next slide that the price of batteries is going down significantly, and you'll see in a minute that the technology of the batteries is changing such that you can get more energy out of a battery before recharging. Worth mentioning how there's been a significant cost reduction in batteries over the years. If we go back 12 years or so, $400 a kilowatt, generally speaking, US price, we're now down to close to 150, and we think it won't be long before it'll be $100 per kilowatt hour. Now, that's a significant drop. I should mention it's the battery pack that we're talking about, not just the battery, all the other technology that has to be built into the bus to actually be able to operate it through the batteries or through hydrogen or whatever. And that's quite expensive, but coming down substantially as well. Although the shortage of particular chemicals such as lithium is a bit of a worry. And there's a strong sense these days to search for other battery solutions that are not dependent on the chemicals that come also from countries that are either at war or are using essentially low-cost labor, which is often called slave labor, to mine this stuff and to use it in the manufacture of batteries. And there's a couple of exciting options, of which one I'm particularly interested in at the moment is using the chemicals found in crab and lobster shells to make batteries more sustainable and eco-friendly. So this is the crustaceans, which are linked to crab shells and lobsters and storage energy known as chitin. And if you combine that with chitin as an electrolyte with zinc, of course, and it turns out that Australia, Peru, and China are the biggest suppliers of zinc, then you can create a renewable battery that's essentially clean in terms of energy efficiency and can actually, over a large cycle of battery time, essentially have no CO2 emission implications at all, including as you dispose of them as landfill. Just to make the point that battery technologies are moving fast, and on the right you can see cell prices, battery cells, euro per kilowatt hour will go up, but in return you'll get greater volumetric energy density, which is really the energy content in relation to its volume, which means you can actually get more kilometers out of a given battery as the new technologies come on board. And so that will actually change the landscape in terms of the rechargeable cycles, but not only that, the costs, and you've got to think about both. Now, the operating costs, interestingly, we often used to say that the operating costs of battery electric buses were considerably lower than diesel buses, but that's very much dependent on the price of electricity. And I've got some examples here. We now know in Europe, for example, that given the high price of electricity, partly linked to the Ukrainian war, is almost eliminating the gap between the operating costs of a diesel bus and electric bus. So in some countries where electric prices are low but starting to increase, that advantage may dissipate. Now, of course, we don't just do this for the costs, we do it for the emissions, but it's a real serious issue because at the end of the day, when operators are putting in tender bids, they need to understand the economics of this, because this is where they would identify the bid prices. And you'll see in a minute, this raises some important implications on what new contracts will look like, which moves me on to this last point about what are the key factors that we need to think about when we are switching to electric or even hydrogen buses. And the operator needs to think about operational issues like route length, topography and electric range, passenger capacity, depot space to facilitate charging and at night and even possibly during the day, and even get an additional depot. In some cases they have to because the depot is too small. Charging infrastructure, what exactly is going to be the power source coming in, and then what is that going to cost, and can they do a deal with the energy authorities to get some time of day discounts and so on. Even the possibility that you could actually sell some of the energy back to the grid if you're a smart operator, which is being talked about in some contexts. And of course all the maintenance costs, which will have to change radically. There are less moving parts. People will have to be retrained to handle electric vehicles, and it's a totally different set of training than it is to deal with diesel. And of course, there's a huge amount of safety issues to do with the potentially higher risk of fires in the depot that are related to the new energy sources through the recharging cycle. But the biggest gorilla in the room to date is the electricity grid, and to what extent it has an interest and a commitment to want to actually support the recharging at the depot, unless we think about other ways of doing it. Now, I haven't got time to go through the details, but what I do want to share with you, this then comes down to research that we published recently on maybe a different way of sharing the risks. It was very clear with the diesel environment that there was operators pretty much knew all the different costs of the purchasing of the vehicle, the costs of the fuel, the operating costs, and so on and so on, and how to finance them. But that has changed because there's a lot of lack of understanding or a huge amount of risk and uncertainty in purchasing and operating vehicles with the new energy sources, be it electricity directly through batteries or hydrogen, which is, of course, originally electricity charged sources, and so on and so on. So we're suggesting that we need to maybe think about in the green transition a different partnership between those who gain to benefit from the new future, which is not just the bus operator or even the tendering authority through a successfully attracted bid, but also the suppliers of buses, the suppliers of depot design and management, and so on and so on. And that leads us to what we call a supply chain partnership contract, which is a bit like a collaborative partnership. And it's not like just asking a bus operator to talk to a bus supplier or a battery supplier and give them a price. It's actually having the battery suppliers and the manufacturers directly involved in sharing the risk of putting in the tender bid. There are some issues to do with unfair competition. I won't go into that. That's for a whole lecture itself. But we have one very good example in Sydney where a bus operator together with an infrastructure specialist, a network designer, went together and won a bid, which was a way of, if you like, a new partnership in sharing a risk, which otherwise might not have been shared adequately in terms of an attractive price to win the tender. Of course, this meant that part of the risk of designing the depot and managing those assets is now falling in another company that may, in fact, use venture capital to contribute to opening up the market for them to be able to bid with a bus operator to build a new business. And I think this is going to be a really important issue when it comes to tendering in the future. And we have done in Australia, working with bus operators, a fairly advanced decision support system to help them understand all the costs and all the risks and how they could share those risks with other parties in order to be a winning tender. So with that point, I'm going to stop and say thank you, and I hope that's a useful setting for what's to come.
Well, thanks, David. Unfortunately, David is not connected right now because it's very late in Australia, but I think he had given us a very good starting point for this discussion. And I would like to ask then our two invited speakers to let us know their experience using electric buses and what they see the main challenges of transitioning to a full electric fleet in all their operations. And we're going to start with Tomás Laverne, who is a manager and an executive on Transdev now in Chile, but he had worked in other areas with Transdev in Latin America and in France. Go ahead, Tomás, as soon as you can share your slides.
Good morning or good afternoon, everybody. Thank you very much, Ricardo and Jose, for the invitation. So I'm going to share the presentation right now. If you can just confirm that you can see it well.
Yeah, we can see it, and I think you need to put it on presentation mode. Yeah, perfect. Go ahead.
So I will present in a few minutes the zero emission evolution within our group. So as you know, Transdev is a global operator. Right now we're operating in 19 countries, but we always propose tailor-made solutions. Today, after the acquisition of First Transit, we operate 58,000 vehicles. And at the end of 2023, we are operating 3,000 zero-emission vehicles, to give you an order of magnitude in different countries. So we are living an ongoing transition to propose alternative solution to diesel buses, but in fact, the reality right now is that we're operating a mix of technologies generally. So the different solutions are coexisting between biofuels, biogas, Euro 6, zero emission, and hydrogen. And clearly, the number of battery electric vehicles is increasing fast and accelerating. And there's a tendency to go towards retrofit and to have interest towards the retrofit too. So as an operator, responsibility is to have a positive impact to protect the environment, create value for our communities, and always take care of security. So to protect the environment, the first we're working on is performance. It means always increase ridership per kilometer, train driver to optimize consumptions, and increase the percentage of zero electronic vehicles. So at global level, we are taking a commitment to reduce our footprint. So we have the Moving Green Action Plan. So commitment by 2030 to reduce by 30%, the greenhouse gas emissions, and to increase by 50% the alternative fleet. So we will see right now how we are navigating towards electric mobility. So we started 10 years ago with some few units to test with pilots, like kind of laboratories, how electromobility worked to learn. And we fixed a target to reach 1,500 vehicles between 2024. In fact, we reached it before time in 2022. And today, we are operating at the end of 2023, 3,000 vehicles. And we clearly see that the evolution is becoming exponential. So if we have a look to the top 5 largest operations within our group, we can see that we started in Europe, for example, in Netherlands, in AML to connect the Schiphol airport and in Eindhoven. This was due mainly to regulation and invitation to introduce electromobility on large scale due to public policies. That went together with a stimulus package from PTAs to help those higher investments. Another outstanding operation we can talk about is the Gothenburg operation, where we operate 161 e-buses. And in most of those European operations, we can see that we work both with pantograph and connectors. It means we have overnight charging strategy together with fast charging strategy in order to reduce the weight of the batteries and to optimize the operations. It means extra cost for infrastructure, but efficiency for the operation. So let's talk now about South American. So we can see that South American is taking the lead in some way on big fleets. We inaugurated last year 406 electric vehicles in Bogota. And this year we reached, in fact, 260 e-buses in Santiago in our operation. So just to make a zoom on those two operations. In Colombia, this Green Mobile operation is part of the SITP. Those are feeder buses and complementary services for the Transmilenio BRT system. And it's a good example of a key project delivered by an operator. So here we are talking about a 50 years contract. Those are 2 contracts awarded together. On one side, fleet plus infrastructure, it means all the capex investment. And on the other side, the operation and maintenance. So we delivered a logistics center of 40,000 square meters for e-buses, one of the biggest at all level after China. And we built it in 10 months. Generally, we advise 1 year is a good implementation period for a zero-emission project. So, as David said, the installed capacity of the grid is a key factor that needs to be available to respect the timeline of the project. Here we are talking about 20 megawatts. So in the different tender process, it's very important to anticipate the capacity required. Switching to the next project, just last number for Bogota. We are talking today at city level of 1,485 electric buses. So it's quite huge, in fact. Mostly on 9 meters and 12 meters vehicles. So now we're switching to Santiago. Santiago is a city that is pushing electromobility with a good rhythm. So for the total of the city, the DTPM Public Transport Authority is now at 1,900 electric vehicles at the end of June 2023. So in our cases, we're operating the north on east to west geography. It's a mix of 9-meter vehicles, 12-meter vehicles, and articulated for the longer lines. You can see in Unit 6. So in this case, contract is a bit different here. We are operating operation and maintenance plus infrastructure. So it means we could choose the different vehicles and implement our charging strategy and charging equipment to be compatible. So those two new contracts together, so the red bus urban operation is 931 new standard buses for 66 services. So we operate 7 public depots, and we have to equip 3 with charging infrastructure. So as you can see, it's a mix. So we have a larger share of electric buses of 268 of different brands. And we operate Euro 5 and Euro 6 vehicles too, with a low emission standard. Part of it were vehicles already in the system that are transferred from an operator to another one when the concessions are changing. So interested scheme too. For us, it's important to have standards within those standards in order to make sure that with the introduction of future electric vehicles that are coming in Santiago, public authorities are talking about 1,000 more electric vehicles for the coming year. So in our case, we implemented the CCS2 European standard at the depot in order to make sure that everything remains compatible in time. So here we have 68 chargers, some of 150 kilowatts, mainly because there are 3 connectors, and some of 120 because in this configuration we are working with 2 connectors, both with sequential or parallel charging, means dynamic strategy for charging. So to try to summarize, but it's a larger topic, electromobility. So what we can say, it's zero emission transition impacts all our business activities as an operator. So battery becomes an asset to take care about. That means we have to implement our charging strategy within all our activities, from scheduling to restoring to driving, maintaining, and new safety condition for mechanics. So it's very challenging and passionate transformation of our industry. The financing became challenging too, because we, as we all know, we are at twice level on CapEx when we talk about bus plus infrastructure. So it's very important to have a good scheme to make those huge financing works. But as we see, we are already doing it with a partnership, as David said, with the manufacturer, with financier, and with PTAs to transform electromobility at industrial scale. So zero emission embarks a whole ecosystem, and there are new schemes that are on different alternatives, project per project, and we don't recommend one alternative, but in some cases, energy as a service can be a good solution. In some cases, an operator can do the integration. In other cases, you have batteries as a service. So there are a lot of schemes, and the project per project, we can evaluate which is the best one. Data becomes strategic to find optimizations. That means that we have to monitor smart charging to forecast operation to remain in the correct ranges of batteries, to extend life cycles, to optimize the cost for the overall system. And that helps us to estimate the best solution for future projects too. It means it's important as we can talk about averages. For example, vehicles have to do about 200 and 250 vehicles. But as one of my colleagues said, in average, mountains are flat. So it's important to understand how each parameters influence in the consumptions and the future performance of the system. And just to finalize this presentation, so we capitalized experience worldwide on electromobility at group level. and we will continue implementing zero emission projects in partnerships with the different players of these big challenges. So I won't extend. I think I'm already used the time, but just to finish, as a global group, we empower freedom to move every day, thanks to safe, reliable, and innovative solutions that serve the common good.
Thank you, Tomas. Very good setting for the topic, and then we're going to leave the space to Neil so that he can present. I think Jose, you are going to share the slides of Neil, and Neil go ahead and present them. Go ahead, Neil. You're muted. You need to unmute yourself.
Well, good morning. My name is Neil Smith. I'm a director and major shareholder of the Kelsian Group. We are like a tiny little Transdev, where we are the largest operator of transit buses in Australia. We have a big operation in Singapore, and we run a certain number of vehicles in Europe. So the next slide is just the map we always show, but that's not really all that important. But we're running between a bit over 3,500 buses, and the jurisdictions we work in are not in general jurisdictions that have been leaders in this transition. So particularly Australia has been a laggard, and Singapore is catching up now, but came from well behind. There are also jurisdictions with very different climatic conditions. In Singapore, most of our buses are double-deck buses running in 30 degrees with the air conditioning at 22. So that's quite different than operating buses in London. And in Australia, it's basically single-deck buses. So our experience of electric buses at present is around 120. And our experience is that in most of the markets we work, apart from London, we are at the sort of the front end. So we're doing the learning. We're seeing what works and what doesn't work. So next one. So we've been on a journey as a company, and it hasn't been an easy journey. And I think it's important as we look at this topic to understand how difficult it can be for bus operators to enthusiastically embrace what we're doing. For us, it began with the outcome of the 2015 COP conference and the realization that rapidly spread through Europe at that time that everybody had to do something. And I remember being at a UITP presentation just after that conference, and the general view of all the operators, the European operators, was that this was absurd. This was impossible, and there was a lot of resistance. And we have seen that resistance in Australia, we've seen it in Singapore, we've seen it in London. Operators do not initially like the sound of this. But unfortunately, it is a mega trend. It's something that is far bigger than us, and we have no choice in what's going on. And one of the interesting changes we've noticed is that back in 2015, a mayor or the head of an authority could say, we're going to reduce emissions, and could offer hybrid vehicles or could offer clean diesel. That's all gone. The only thing a politician can offer now is zero. And everything else is seen as a compromise. And I think that's come out of the diesel consumption scandal of a few years ago, that diesel is a distrusted fuel by environmentalists, and those pushing for change are going to want zero emission, no compromise. We decided by 2018 that we actually had to make this change, particularly in Australia. And if we were going to make it, we had to try to be at the front. And that was a very difficult decision for what was then a privately owned company. We didn't have access to a lot of capital, and there was very little support from government. But we made that decision in 2018, and we've been on a journey since. And interestingly, I've gone from being very skeptical about this to a true believer. I enthusiastically push the business in this direction because I think there are so many positives with electric vehicles that we didn't understand when we began. And we are committed to getting our fleet to all zero. We don't put a date on it because all the decisions are made by governments. And if you know what date governments are going to make a decision, you're a lot smarter than me. We can't predict that. So next slide, please. Now, one of the things that hit operators when this topic arrives are basically a whole lot of fears, really fundamental fears, and these fears drive resistance, and they drive confusion, and they drive disruption. So the first thing is that operators understand diesel. They've been working with it all their life. They understand how to make a diesel bus optimize. They feel comfortable with diesel. And to take that away is to take away a very large part of their intellectual property and their competitive advantage. And so that leads to fear. There are fears around operations. What will the range of these buses be? What will their weight be? How many passengers can they carry? How long will it take to refuel? And those fears have not been helped by a large amount of misinformation in the market from potential suppliers. So many operators are just deeply suspicious of what they're told on those four subjects. Operators have a huge investment in engineering, in skills to work on diesel buses, and in equipment and in work practices. And they see this transition again as cancelling that investment and pushing them into a new area that they don't understand. The finance issue is an interesting one because you could almost see it that as you go to electric buses, you're shifting costs from operating costs to capital costs. You're sort of making a bus company a bit more like a train company with much higher capital costs, but in many cases offset by lower operating costs. And that creates a lot of problems for companies that don't have access to capital, but also for companies that have short-term contracts. There is a fear in terms of dealing with manufacturers because in many cases they're moving from manufacturers they've dealt with sometimes for generations, and they're moving to new manufacturers. And I'll say this cautiously, but the reality is for many, they're moving from European manufacturers to Chinese manufacturers. And as an Australian, I will say that we consider China an unreliable trading partner because of our recent history. And so it's a very different relationship with a BYD compared to a relationship with a Volvo who you've known for 50 years. Now, that's probably politically incorrect, but that's how people think. And then regulation. Everybody's afraid here, governments, transit authorities, operators, because most regulation is built on assumptions that are only true with diesel buses, and they start to fall to pieces once you move to electric. Next slide, please. And so these are the barriers. There's the barrier of getting power. Can you actually get it, which is the biggest one? And if you can get it, what does it cost? Particularly, what does the infrastructure cost? If new power supply has to be extended towards your depot. There's an issue of depots. Depots now have to be bigger, but also their location is driven by the availability of power, not the availability of cheap land. Vehicles are a barrier because what is available, and if I buy this vehicle, will it be supported? Our employees have to go through reskilling and adaptation. We have to raise a lot more capital, even though it will be offset by lower operating costs. And I'll say it, I think quite loudly, in most cases, we move into a regulatory mess. Next slide. But are there solutions? Well, I think the solution to dealing with the grid must involve a deeper relationship between authorities and the power companies. It is absurd to think that a local bus company can negotiate on an equal and transparent way with a utility. The fact is we have no power, and I've seen many examples as we've gone down this road of exploiting, bullying, price gouging by utilities. And we're too small and too weak to do anything about that. That has to be a government role. Similarly, with depots, it will surprise no one that the same governments that tell you to go to zero emission often have planning laws that prevent you going to zero emission. In particular, urban planners do not like transformers because of what they see as the risk of explosion. And it can be very slow and very difficult to get planning approval to put in a large-scale electric bus operation. With the manufacturers, I would hope there will be a solution there, although I am surprised at the tardiness of the response from some of the European companies who are now appear to be well behind the 8 ball on this transition. But we, to be honest, have found that the vehicles we've bought, and in Australia, they are all Chinese buses, they've worked much better than we expected. So let me balance my earlier comments. We were afraid of that. Our fears were misplaced. And that's interesting because I know in the US, there's been some terrible experiences with imported buses, and we were expecting that, but we did not run into it. We need to do a lot more training. And what we found is our staff, particularly our engineering staff, are ready for that. They're enthused by it. They want to make the change. And that's turned out much easier than we expected. Finance is very tricky, in part because nobody knows what an electric bus is worth in 10 years' time. And so a finance company has great difficulty constructing a finance contract. And often they cover their risk by just increasing the price. So finance is a real challenge, particularly for smaller operators, because they do have a much higher upfront cost, and it's a long payback period. Regulation, as I've said before, is a huge problem. We work with about 12 different authorities, and I could say that I don't think any of them have come up with a regulatory design that's fit for purpose. They don't want to give up the history, but they can't come to grips with the need for longer contracts. They can't come to grips with how you price electricity, which can change by the second as compared to diesel. And they want it, but they don't really know what to do. And I can't think in any area where we run where I could say, go and look at that city. They know how to regulate a contract through the transition. And all that really comes to the last point, that these changes require cooperation between multiple parties. Some of them private sector, some of them government, all with different priorities. And certainly as an operator, we are normally the smallest person in the game. Next slide. But I do believe there are great opportunities. And I think I mirror what my colleague from Transdev said, that we are using this transition to represent our business in a more positive light. If you're a bus operator running diesel buses, you're part of the problem. If you're a bus operating electric buses, you're part of the solution. And it's surprising to us what a difference that makes, what a difference it makes to our drivers' self-image and our mechanics' self-image, what a difference it makes to our relationship with political players, what a difference it makes with our relationship with our passengers. It is quite possible as you go on that journey to reset the industrial relations in a company. We believe that there will be long-term savings. We have watched the cost of various components drop dramatically. And to give an example, and I know it's mentioned in David's paper, an AC charger in Sydney 18 months ago cost 35,000 Australian dollars. An AC charger today costs 8,000 Australian dollars and is a quarter the size. So you are seeing, in terms of the evolution of this process, very, very rapid technical change, very rapid changing in pricing. And it makes running a bus company, you're at the front end of innovation. You're at the front end of change. And that's a very positive thing for everyone. Now, I've put the planet at the bottom because we are trying to save the planet, but I think if every bus was electric, it doesn't make a measurable difference to the amount of greenhouse gas in the world. But being part of the process that reduces greenhouse gas, again, is a positive. It's something we as a company want to do, our staff want us to do, our passengers want us to do, and our regulators want us to do. Thank you.
Thank you very much, Neil, and I thank both of you for sharing your thoughts on this transition and putting the challenges ahead of going forward to full zero-emission buses.